Hello everybody. Today we are going to discuss on the topic maturity and ripening process. As an introduction, I would like to state that maturity at harvest is the most important factor that determines storage life and final fruit quality. Immature fruits are more subjected to shriveling and mechanical damages and are inferior in quality when ripe. Overripe fruits are likely to become soft with insipid flavor soon after harvest. Fruits picked either too early or too late in their season are more susceptible to post-harvest physiological disorders than fruits picked at the proper maturity. Similarly, vegetables are harvested over a wide range of physiological stages, depending upon which part of the plant is to be used as food. Therefore, harvesting of fruits and vegetables at proper stage of maturity is of paramount importance for attaining desirable quality. Then, what is maturity? Maturity is generally the developmental state of the fruit on the tree, which will result in a satisfactory product after harvest. The use of the word maturity is restricted to the development on the tree and before respiratory upsurge in autocatalytic fruits. The maturity has been divided into two categories, that is, physiological maturity and horticultural maturity. Physiological maturity, it is the stage when a fruit is capable of further development or ripening when it is harvested, that is, ready for eating or processing. Then horticultural maturity. It refers to the stage of development when the plant and plant part possesses the prerequisites for use by the consumers for a particular purpose, that is, ready for harvest. Now let's discuss the physiological development of fruits and vegetables. During growth and development, many physical and chemical changes occur in fruits. These changes are mostly gradual and continuous. The lives of fruits and vegetables can be conveniently divided into three major physiological stages following initiation and germination. These are growth, maturation, and senescence. However, clear distinction between the various stages is not easily made. Growth involves cell division and subsequent enlargement, which accounts for the final size of the produce. Maturation usually commences before growth ceases and includes different activities in different commodities. Growth and maturation are often collectively referred to as the developmental phase. Ripening is a term reserved for fruits and is generally considered to begin during the later stages of maturation and to be the first stage of senescence. Senescence is defined as the period when anabolic, that is, synthetic, biochemical process give way to catabolic, that is, degradative process, leading to aging and death of the tissue. Development and maturation are completed when the fruits are still attached to plants, but ripening and senescence may proceed on or off the plant. Fruits are generally harvested either when mature or when ripe, although some fruits that are consumed as vegetables may be harvested even before maturation has commenced. Then, let's discuss fruit ripening. The ripening of the fruit undergoes many physico-chemical changes after harvest that determines the quality of the fruit purchased by the consumer. Ripening is a dramatic event in the life of a fruit. It transforms a physiologically mature but inedible plant organ into a usually attractive olfactory and taste sensation. Ripening marks the completion of development of a fruit and the commencement of senescence. and it is normally an irreversible event. A list of changes that has taken up in the fruit during ripening has been discussed. The changes that may occur during the ripening of fleshy fruits are seed maturation, color changes, abscission, that is, detachment from the parent plant, changes in respiration rate, changes in tissue permeability, changes in rate of ethylene production, changes in composition of pectic substances, that is, softening, changes in carbohydrate composition, organic acid changes, protein changes, production of flavor volatiles, development of wax on skin. Ripening of fruit is generally associated with the release of ethylene hormone and an increase in the rate of respiration. This is generally true for climacteric fruits, but not for non-climacteric fruits. The change in respiration and ethylene production can best explain the mechanism of ripening. Respiration changes during ripening. A major metabolic process taking place in harvested produce or in any living plant product is respiration. Respiration can be described as the oxidative breakdown of more complex material normally present in the cells, such as starch, sugar, and organic acids, into simpler molecules such as carbon dioxide and water, with the concurrent production of energy and other molecules which can be used by the cell for synthetic reaction. Respiration rate of a produce is an excellent indicator of metabolic activity of the tissue and thus is a useful guide to the potential storage life of the produce. Respiration rate per unit weight is highest for the immature fruits or vegetables and then steadily declines with age. A significant group of fruits that includes tomato, mango, banana and apple shows a variation from the described respiratory pattern. In this, they undergo a pronounced increase in respiration coincident with ripening. Such an increase in respiration is known as respiratory climacteric, and this group of fruit is known as the climacteric class of fruits. Thus, fruits on the basis of their respiratory behavior can be classified into climacteric and non-climacteric fruits. Then coming to climacteric fruits. Climacteric fruits are generally termed as the fruits that continues with ripening even after harvesting. In such fruits, ripening is associated with rapid increase in respiration. This sudden upsurge is called climacteric rise in respiration. These fruits also emit ethylene during ripening and respond to ethylene treatment, that is, they can be ripened by treating with ethylene. And then non-climacteric fruits. These fruits show neither a rise in respiration nor an associated production of ethylene during the ripening process. The ripening is normally completed on the parent plant and cannot be ripened after harvest. Now we'll discuss the effects of ethylene during ripening. The process of fruit ripening is chiefly regulated by a gaseous plant hormone called ethylene. This phytohormone is said to regulate the expression of several genes involved in fruit ripening so as to modulate the activity of various enzymes involved in the process of ripening. Several factors affect the speed at which the fruits ripen. Natural process of fruit ripening is accelerated by using certain chemicals. For example, bananas are picked when green and artificially ripened after shipment by being gassed with ethylene. As a fruit ripening hormone, it is produced in varying quantities depending on the type of fruit, but when the concentration of ethylene reaches zero point 0.1 to 1 ppm, the ripening process in climacteric fruits is considered irreversible. While there are other factors involved in this triggering of the ripening process by ethylene, it is essentially a universal ripening hormone. Calcium carbide is the chemical that was used widely by the Indian farmers and the fruit vendors for ripening of many climacteric fruits. But like in other countries, in India also, use of calcium carbide is strictly banned as per POFA Act. The only safe and worldwide accepted method is the use of ethylene, which is a natural hormone for ripening, which is done under controlled temperature and relative humid conditions. It is a degreening agent, which can turn the peel from green to perfect yellow, as in the case of bananas and citrus fruits, and maintain the sweetness and aroma of the fruit. Thus, value addition in the fruit is possible. Let's discuss the chemical changes during maturation. A lot of chemical changes occur in the fruit and vegetables during its growth and development stages. During ripening, complex, multi-structured compounds are broken down to simple compounds, besides synthesis of newer compounds which enhance the olfactory characteristic of fruits and vegetables. Let's discuss color. Color is the most obvious change that occur in many fruits and is often the major criterion used by consumers to determine whether the fruit is ripe or unripe. The most common change is the loss of green color. With a few exceptions like avocado and Granny Smith apple, climacteric fruits show rapid loss of green color on ripening. Many non-climacteric fruits also exhibit a marked loss of green color with attainment of optimum eating quality. For example, citrus fruits in temperate climates, but not in tropical climates. The loss of green color is due to the degradation of chlorophyll structure. The disappearance of chlorophyll is associated with the synthesis and or revelation of pigments ranging from yellow to red. Many of these pigments are carotenoids. Carotenoids may be synthesized during the development stages of the plant, but they are masked by presence of chlorophyll. Following the degradation of chlorophyll, the carotenoid pigments become visible with other tissues. Anthocyanins provide the red-purple color of fruits and vegetables. They produce strong colors which often marks carotenoid and chlorophyll. Then softening. Fruits normally soften progressively during ripening. Although exact biochemical mechanisms have not been fully established, it is believed that softening is largely due to the breakdown of starch and other non-pectic polysaccharides in the pulp, thereby reducing cellular rigidity. Then coming to carbohydrate. The largest quantitative change associated with ripening is usually the breakdown of carbohydrate polymers, particularly frequent near total conversion of starch to sugars. This has the dual effect of altering the taste and texture of the produce. The increase in sugar renders the fruit much more sweeter and therefore more acceptable. Even with non-climacteric fruits, the accumulation of sugar is associated with the development of optimum eating quality, although the sugar may be derived from the sap imported into the fruit rather than from the breakdown of starch reserve of the fruit. Next is organic acids. Although the development of sweetness is important, the overall fruit flavor is also influenced by organic acids. Thus, organic acid helps in forming the desirable sugar-acid balance necessary for a pleasant taste. Usually, organic acids decline with ripening as they are respired or converted to sugar. Acids can be considered as a reserve source of energy to the fruit and would therefore be expected to decline during the greater metabolic activity that occurs on ripening. Next is nitrogenous compounds. Proteins and amino acids are minor constituents of fruits and, as far as it is known, does not have any role in determining the eating quality. Changes in nitrogenous constituents do, however, indicate variation in metabolic activity during different growth phases. During the climacteric phase of many fruits, there is a decrease in free amino acids, which often reflect an increase in protein synthesis. During senescence, the level of free amino acids increases, reflecting a breakdown of enzyme and decreased metabolic activity. Next, we'll come to phenolic compounds. Phenolics, such as tannins, are polymerized to insoluble compounds, resulting in a reduction of astringency in the ripe fruits. Tannins are perhaps the most important phenolics from the point of view of fruit utilization because they can give fruit an astringent taste. As fruit ripens, its astringency becomes lower, which seems to be associated with a change in structure of the tannins rather than reduction in their levels, in that they form a polymer. Phenolics are common in many fruits and are responsible for the oxidative browning reaction when the pulp is cut. There is a loss in the total phenolic contained during ripening, which is associated with a loss of astringency levels of polyphenols. Next, flavors and aroma. Flavors are the subtle and complex perception that combines taste, smell, and mouthfeel. The characteristic flavor and aroma of ripe fruit is due to the production of a complex mixture of individual volatile components. At least 350 components have been shown to occur in ripe bananas, and their synthesis is generally occur relatively late in the climacteric, with acetate and butyric esters accounting for about 70% of the total volatile emanations. However, besides the volatile compounds above, other esters as well as aldehydes, alcohols, and ketones have been associated with fruit flavors, and their production rate can increase during ripening. Now, coming to the conclusion. At some stages during the growth and development of fruit and vegetables, the produce is recognized by the consumer as having attained the optimum eating condition. Estimation of maturity is in effect the estimation of performance of the fruit after harvest under predicted conditions. Thus, production of good quality ripened fruit depends on the stage of maturity at harvest. Ripening is associated with an increase in the rate of respiration and production of ethylene gas. Externally applied ethylene gas can initiate ripening and degraining. A lot of chemical changes also occur during ripening, the most obvious being the change in the color of the fruit, and the others may be softening of the fruit and development of flavor and aroma.